Hey guys, welcome to my channel. Today we're going to look at arithmetic progression. We had looked at geometric progression, and it's quite a simple code, so this will take like a short second for you. Um, this is the second part of the progression series, and this is just basically like looking for first term, a common difference, and then the nth term. The nth term is the infinite number of terms that you may want, and I thought of giving it a truly look. Just to give a bit of background of arithmetic progression, um, it's a sequence or a series of numbers that act upon a common difference of a particular action. It can be a negative difference or a positive difference, like the short example we have here: 2, 5, 8, 11, and 14. The difference is 3. That being said, guys, just by the fact that you've looked for this, I'm assuming you're already comfortable with the concept of the arithmetic progression, and this is the formula you need to focus on. The nth term to which we need to find is equal to the first term plus um, the n, which is the next term, times the difference. So basically, this is like saying to get 5, we need 2 plus 3. Yeah, and this gives you like the difference, if you get what I'm saying. But if not, don't worry, we're about to explain it fully. Now, that being said, we've used a few terms we're going to keep using, of which is a, n, and d. We're just going to define them now. We're going to say a is going to be our first term, so we say a is equals to, we want it to be an integer, so we say int. We want to give an input. This will simply give you the chance to input any number you want. We'll say input, and we'll ask you what's your first number, right? That being said, we'll go to the next and say the next term here should be d, yeah, and say it's also an integer. We want to give an input. Yeah, we want to give an input. So say input what's your common difference. Alright, that being said, we're going to go to the next, which is n. Don't worry about that, guys. It's totally normal. And here we're going to say int, again, input. Then we say, sorry, I hate tabs. What's your, sorry guys, sorry, this should be a statement. What's, wow, what's your nth term, right? We can even put a question mark there. So with this, we have already defined the parameters to which we're going to work in. From here, we're just going to give the AP and then the formula. So from here, we just say print. We're going to print, and we're going to print a short statement. This is the arithmetic, let's say series, right? So this will print the statement, and then the series will follow right below it. Up to this point, I'd like to believe you're still together, stronger than ever. All right. So m, we're going to introduce a new term. We call it m. Yeah, equal to 1. Yeah. What? Sorry, guys. Sorry. There's a problem of writing too many functions. You just pop up on your screen and say m equals to 1. Yeah. If seeing these things, don't worry about it. Don't worry too much. It's just undefined. So we're going to define it. That's what we're doing now. I'm going to say m equals to 1. Yeah. And then we're going to use a loop. Now here's where the magic is. Now remember, this is the formula. So anything that we write, if it doesn't resemble this formula, we don't want it. And so that being said, we're going to use a formula. At this point, you can choose any letter to replace m with. It can be x, as long as it's not a, n, or d. It can be x, can be y, can be z, can be g. Yeah. Personally, we prefer g, but we had already started. Can change it, but you get the point. Yeah. We're just going to recreate that formula, and that would be, all right, let me just use g. Yeah. Said it too much. G, because I'm the G. I'd like to think so. Then yeah, I'm just going to say while. Yeah. While g is greater than or equal to n. What do you want to do? Do this. What do you want to do? You want to give this function, this one right here. So we'll say a, the first term. Sorry. We'll say let's say tg, the g term, yeah, tg, the g term is equals to a, yeah, plus into bracket n minus 1 times what? D. See, this is just the same as this. So you're on the right path. Clap for yourself. You're on the right path. Then after this, we're just going to say, you know what, print tg. Print tg. See, you're good. You're good up to here. You're actually good. And then we're just going to give it one final parameter, of which the final parameter will be what? It will be to do let's say g equals to g plus 1. This simply means move to the next number. Yeah, move to the next number. So keep going until you get to that nth term. All right. So guys, with this code, you can definitely run it. So to give a bit of spice, I just break. Yeah. Then print print. There's a personal statement to you guys. Subscribe to Geo's sorry rhymes my name. Right? Thanks guys. Okay, so a moment of truth. Okay, I can see here we have two problems. Just want to find them and pluck them out. Just pluck them out, you know what I'm saying? Alright. That seems to be the problem. That is it. G is equals to 1. Print G is equals to greater than that. Let's see. terminal, new terminal, problems, unexpected indentation. Uh, Alright, let's, yeah, everything's fresh as a daisy. Told you guys some minor stuff. Just anyway, CD desktop. Now, what I'm doing right now is simply to open my virtual network, um, and I'm just going through the path to it, to which I have created it. So here we're going to say Python ap.py, which is how I've saved this file. All right. So what's your first number? We're going to say 2, enter. What's your common difference? We're going to say 3. What's your nth term? We're going to say 5. And this is the arithmetic series. Subscribe to. Now, we remove this break. Sorry, just realized something. We're going to print this again. Let's say 2, 3, 5. And that's what we need. Guys, there's a bit of something. There's a bit of something that needs to be corrected. Uh-huh. Uh-huh. Oh, yeah. Yeah, I just seen it. Guys, forgive me. This should be G. This should be G. Guys, I am sorry. I'm so sorry. Correct that. I say 2 again. Say 3 again. Then I say 5 again. And this is what you need, yeah? This is what you need. So 2, 5, 8. This is your series. So the best part about this type of code is you can put any number. We can say 123. You can say 234. You can say 345. All right. And you have those infinitely many terms like that. And then right below it, there's the sweet message of subscribe to GS Rhymes. And kindly, if you can, guys, please do subscribe. I am grateful. I hope you've stayed to the end of the the video. Check out my other videos: Fibonacci sequence, dosage on R, geometric progression, which is concurrent with this one. Like, subscribe, and share. And see you in the next video. Cheers. Happy coding, guys. Cheers.